Hi everyone. In this video, we will discuss about the application of the differentiation, especially to see or to analyze the graph behavior. We will discuss about increasing function, decreasing function, and stationary point. So let us start our discussion. This is the learning objective that we hope you can apply the differentiation to find the increasing and decreasing region of a function. And then to locate the stationary points and determine the nature of the stationary points. And this information can be used to help us in sketching the graph. So let's start with the first very beginning concept. From the previous lesson, we know that the differentiation is a gradient of the tangent. Yeah, if you remember the first principal method, when we do the limit of f c plus h, in here the x value is c, so c plus h minus fc over the h is equals to delta y over delta x, which is a gradient. If you remember on the previous video, when we finding the tangent of a graph, introduce you to the differentiation. So using that information, that the first derivative of a function is the gradient of the tangent. Yeah, you can see here, so we can find the tangent here, the gradient of the tangent using the differentiation. Now, if we see furthermore, like this function, I can divide this function into a certain region based on its behavior. It's the trend of the graph. If you see in this part, the graph is increasing until this point and then decreasing and then increasing. So from here, we can see that a function f is increasing if in the given interval AB, yeah, in the given interval AB, f x1, so x1 is the first point, and x2 is the other point, yeah, where x1 is smaller than x2. So for example, x1 in here and x2 in here. The value of x1, will be smaller than the value of fx2. So this is an increasing function. And a function is a decreasing function if the f of x1 is here, and x2 is here. For example, so if the f x1 is greater than or higher than fx2, so this is a decreasing function. Now, how do we know the function whether it is increasing or decreasing? If we see the trend of the function, yeah, the graph is increasing can be represented by the gradient of the tangent. In here, you can see that the gradient of the tangent, when the graph is increasing, is a positive gradient. So we say that the first derivative, which is the gradient of the tangent, is greater than 0 or positive value. That's an increasing function. And for the decreasing function, we see if we draw the tangent the tangent line will have the negative value. So the first derivative is less than 0. So from this information, we can find that for an increasing function, the gradient of the tangent should be positive or greater than 0. And the gradient, when the decreasing function, the gradient of the tangent should be a negative value or smaller than 0. Let's see the example. Determine the intervals where the function f(x) is increasing and where it is decreasing. So, based on this information, we can see the increasing and decreasing function from the first derivative. So we have to derive this function, x cubed minus x squared plus 1 is derived by become 3x squared minus 12x. And then we try to make it 0 because we want to find the region whether the function is positive and negative. So we make it equalize to 0, and then we factorize 3x times x minus 4 using the factorization equals to 0. So that means we have x equals to 0 or x minus 4 equals to 0. So we have x0 and x equals to 4. So we have two values, two solutions of x when the first derivative equals to 0. So if we draw a number line, I put 0 and 4 here. And then I do the sign check. For any value smaller than 0, for example, negative 1, I do the sign check here. 3 times negative 1 is negative 3. Negative 1 minus 4 is minus 5. So negative 3 times negative 5 is a positive. So we will have a positive value for any values of x that smaller than 0. We do check again, for example, 1. So 3 times 1 is positive 3. 1 minus 4 is negative. So positive times negative is a negative. And we do again 5, for example. 3 times 5 is positive. 5 minus 4 is also positive. So positive times positive is a positive. Now, from here, we know that this is the result of the first derivative, the gradient. So the gradient is positive when x is smaller than 0. So we can say the function is increasing in this interval from negative infinite until 0. So x smaller than 0 is increasing, as well as when x greater than 4. X greater than 4, the function is increasing. And when the gradient is negative, so when the value of x between 0 until 4, the f is decreasing. So from here, we can check the increasing and decreasing function from the first derivative. If it is positive, it is an increasing function. And if it is negative, it is a decreasing function. So if you draw this graph, so 0 and 4 will be when the first derivative equals to 0. And if we draw it, you can see that for the value less than 0, see, for x negative is an increasing function. Between 0 until 4, it's a decreasing function. And after 4, greater than 4, it's an increasing function. And this is exactly the same as the result of the calculation, of our calculation, yeah? Now, what are these points. If the increasing function is when the first derivative, the gradient, is positive, so at these points, we see that the tangent to this point is a horizontal line, which is the gradient is 0. So that means since the gradient is equals to first derivative, so at this point, the first derivative should be equals to 0. So we call this as a stationary point. So from our example, we have two stationary points when the first derivative is equals to 0. So we have this, and we can differ them by the position. The first one is a local maximum, and this one is local minimum because if the value of y is smaller than, less than the local, the other value. Okay, for example, so the same equation, the same function. So we find the stationary point. So we derive it first. 3x squared minus 12x, the same as before, and we make it 0. So at the previous example, we make it 0 to find the stationary point. So 0 and 4 are the stationary points. You can see 0 and 4 are the stationary points, and the value between before and after the stationary point will be an increasing and decreasing function because they are stationary point and they are maximum or minimum, for the nature of the stationary point. So in here again, we got the same result. So 0 and 4 in here are the stationary point. And when we do the sign check, we got this, positive, negative, and positive. And from here, we can find if we replace the value. For example, f0, if we replace the stationary point to the function originally, we will get it equals to 1. And then if we replace the x equals to 4 to the function fx, we will get it equals to negative 31. So from this result, we can say that the 0, 1, the point 0, 1 is a maximum point, while the coordinate 4, negative 31 is the minimum point. You can see here, when x equals to 0, this is the coordinate 0, 1, and this is the 4, negative 31. So 0, 1, 0, 1 is the maximum, and 4, negative 31 is the minimum point. So that's we call as the nature of the stationary point. We have 3 natures of the stationary point. In this graph, we only see 2, the maximum and minimum point, but we have 3. So this is a minimum point. This is the minimum point. It happened when dy dx, the first derivative equals to 0. This is the maximum point. It is when dy dx equals to 0. And this is the point of inflection. You see if there is no change in the gradient, So all of them are the stationary point. So for all of them, the dy dx, the first derivative, is always equals to 0. So for this stationary point, we have 3 natures. We have minimum, maximum, and point of inflection. Now, how do we define the minimum or maximum or point of inflection. Previously, we try to see from the number line, and the number line contains the positive and negative sign in here. If you remember, this number line is coming from the first derivative, which is the gradient. So the plus and minus here are the sign of the gradient. The gradient is positive, is increasing function. The gradient is negative, is a decreasing function. And we can find using this method, this is the first method, by the gradient check. So if before the stationary point we have a negative gradient, which is a decreasing function, and after the stationary point we have positive gradient or increasing function, so we have a minimum point. Yeah, the gradient is 0 at minimum, and the gradient change, yeah, goes from negative to 0 to positive. So from negative, 0 and positive. So this is a gradient check for minimum point. And if we see from the previous example, you can see the minimum point here at 4, negative 31. So you can see here the gradient sign is negative, 0 at stationary point, and positive after stationary point. This is a minimum point. How about the maximum point? So the maximum point has the positive gradient before the stationary point and negative gradient after the stationary point. So the gradient is changing from positive to negative. So this is a maximum point. If you see the example, the maximum point is at x equals to 0, yes, 0, 1. And you see when x equals to 0, the stationary point, the gradient before the stationary point is positive. And the gradient after the stationary point is negative. So this is a maximum. Because it is increasing, positive here, 0, and then negative, decreasing. So this is a maximum point. Now, we can do the second derivative check instead of using the first derivative check, the gradient check, yeah? We can do the second derivative check. So, how do we find that? Using the second derivative. Now, the second derivative is the first derivative of the first derivative. So we derive the first derivative. Yeah. Second derivative is of the y respect to x. We will have it by differentiating the first derivative. So we can say that the second derivative is the change of the gradient. So we can see if the change of the gradient is from negative to positive, that means the change is increasing. It is a minimum point. So we can say the change of the gradient is increasing, positive, yeah, from negative to positive. So when the second derivative is greater than 0, we will have minimum value, yeah, minimum point. And if the change of the gradient is from positive 0 until negative, so the gradient is changing, decreasing, yeah, from positive to negative. So the gradient change decreasing, yeah. So that means the change of the gradient is smaller than 0, yeah, since decreasing is smaller than 0. Huh? So the second derivative is smaller than 0, and we have the maximum point. How about if there is no change? If we see from the stationary point, the gradient is negative. After the stationary point, the gradient is negative. So there's no change. As well as this, before the stationary point, it is a positive. After the stationary point is also positive. So we can say that there is no change in gradient from this example. So the second derivative, the change of the gradient is equals to 0 because there is no change. So the second derivative is equals to 0. So we call this as point of inflection. Now, if you see in here, we have two types of point of inflection. This is the type 1. When the stationary point, the first derivative is equal to 0. And this is the point of inflection type 2. You see that this stationary point is not really a stationary point because the gradient here is not 0. In here, the gradient is 0, right? In here, the gradient is 0. In here, the gradient is not 0. So this is the second type of the point of inflection. So they still have the same gradient before and after. So this is point of inflection type 2, where the stationary point is not equals to 0. The first derivative is not equal to 0. Yeah. So this is the conclusion of our discussion. So if we have a minimum point, this is the minimum point, it will happen when the first derivative equals to 0 and the second derivative is greater than 0. It changes positively from negative to positive. The gradient changes from negative to positive. So the second derivative is greater than 0. The next one, maximum, is when dy over dx, the first derivative equals to 0, and the second derivative, the change of the gradient is 0, less than 0. It changes from positive to negative. Yeah, the gradient changes from positive to negative. And for the point of inflection, in here, yeah, this is the type 1, yeah, the type 1. So the stationary point is when the dy dx equals to 0. And the second derivative is equals to 0 as well. This is the type 1. If type 2, the second derivative is 0, but the first derivative is not 0. So if we have this, dy dx equals to 0, the second derivative is greater than 0, we have minimum. If we have dy dx 0, and the second derivative smaller than 0, we have maximum. And we have, if we have the second derivative 0, when the dy dx equals to 0, it is a point of inflection. Yeah. Now, this is the example. Classify the relative extreme of fx using the second derivative test. So we try to use the second derivative. Okay. So that means we have to find the first derivative, yeah, to find the stationary point. So we derive this function once, and we have 4x cubed minus 12x plus 8x. And then we make it equals to 0 to find the stationary point. Then we factorize. So when we factorize, we have 4x, x minus 2, and x minus 1. So that means when it is equals to 0, we will have the x values are 0, 1 from here, and 2 from here. So there are 3 critical values or 3 stationary points. 0 from here, 1 from here, and 2 from here. Now, these stationary points, now we check into the second derivative. So we derive this first derivative. For x cubed become 12x squared, negative 12x squared become negative 24x, plus 8x become positive 8. And we check all the stationary values. So we check where x equals to 0, the result of the second derivative is 8, which is positive value. When x equals to 1, put into the second derivative, we have it equals to negative 4, which is a negative smaller than 0. And when f is second derivative, when x equals to 2, yeah, the stationary point equals to 2, we will get 8 as well, and this is positive, greater than 0. So if you remember, when second derivative is greater than 0, this is a minimum. And when it is negative, it's a maximum. You can see here, the value of the second derivative is minimum, negative. So this is a maximum value. And the second derivative when x equals to 0 and 2 are positive. So this is maximum, minimum. And if you check by the coordinates, you put 1 to the function here, 1 minus 4 plus 4 minus 5, it will be equals to negative 4. And if you put 0 and 2 here, you will have negative 5. So from this, we can say that this is smaller than this. So this is minimum, this is maximum. Yeah, because the y values here is greater than the y values in when x equals to 0 and x equals to 2. So from here, from the second derivative, we can check the minimum and maximum. It will be maximum when x equals to 0 and x equals to 2. And minimum when x equals to 1. If we draw using the Desmos, we will see that these are the 3 stationary points, x0, x1, and x2. It is maximum at x equals to 1. See, this is a maximum turning point when x equals to 1. And it will be minimum when x equals to 0 and 2. So when x equals to 0, this is a minimum turning point, and this is a minimum turning point as well. The results are the same as the calculation we did. So that's all the discussion for today. So hopefully you can understand it better about the stationary point and its nature and the behavior of the graph. That the graph can be an increasing function, decreasing function. And the stationary point, we have 3 natures. We have minimum turning point, maximum turning point, and point of inflection. We can check it, the nature, using the second derivative, as well as from the gradient, the first derivative, check. Okay, I think that's all for me for this video. Thank you for watching and bye.